All right, we're going on to a new chapter, electric charge. In this chapter, we'll talk about electricity, and we'll blend in magnets with that as well, because they both are related, and how we use them. For electric charge, all matter is made of particles called atoms. We've been through this before. The three of the most important particles are the protons, the neutrons, and electrons. And as you can probably imagine, the part that we are interested in going forward with electricity are the electrons. Those little suckers are what we harness to power our devices up. Both electrons and protons have a basic property called a charge. And charge is something that you can't see or weigh or define. So negative charges are the opposite of the positive charges. And a lot of times I tell folks to think of it as a magnet. North and south poles, they're opposites and they attract. And like charges and like poles on magnets repel. And often, you'll see at the end of all this section, in a couple of days, that we use magnets to create electricity. So they are very closely tied. You can see the effects of charge. The static. Bad hair day there. Protons have positive charge and electrons have negative charge. Again, stuff we've discussed previously. Protons and electrons have equal but opposite charges. And neutrons are neutral and have no charge at all. And again, the part we use for electricity are the electrons out here. And we actually push those around through a material like a wire to create a current flow. The protons and neutrons stay in the nucleus the whole time. Ben Franklin discovered the charges. Charges exert forces that push or pull. So electrons are zipping around the outside, but the negative charge being held closely by the protons, positive charge. Forces of attraction exist between opposites, again, like magnets. So you can think of this as a North Pole, South Pole kind of a thing. They attract. This attraction is what holds electrons around the nucleus. A force of repulsion exists between like charges. So plus and plus, they push away. Negative and negative push away as well. And then the like charges attract. The different charges attract. Now there's a field. An electric field extends outward through the space in every charged particle. Just like a magnet has a field, charges have a field. And the stronger the charge, the more field there is. The stronger the magnet, the bigger the field. So it's proportional to the strength of the charge as the size of the field. A charged particles moving into electric field or other particles are pushed or pulled depending on the charge. Pluses push pluses and minuses push minuses. And plus and minuses both come towards each other. And the charge is always strongest near the charge. Again, like a magnet. The closer you get to the tip of the magnet, the stronger the charge. As the distance increases, electric charge or electric field decreases. Electric field is always strongest near the charged particle. Again, we'll get the magnets. You'll see a very similar field going around magnets from the poles, north and south poles.